Good day to everyone. Let's see how the control circuit is wired for a star-delta starter, when the motor can run forward and reverse. Wiring from the three-phase power supply to the motor is not shown here, as it was discussed earlier in a separate video. To begin with, here we have the induction motor, and two magnetic contactors for forward and reverse operation, and also another two for star and delta operation. Two pole breaker switch and a star-delta timer were also added to the control circuit. Further, we need two start push-button switches and a stop push-button switch. First, wire the two-pole breaker with single-phase supply, and the phase wire from its output terminal is connected to the terminal number 95 of the thermal overload relay. Control wiring need to go through these normally closed terminals 95 and 96 first, since it can break the circuit if motor overloads during operation. From terminal 96, wire the forward run push-button switch through the stop push-button switch. Then, take the wire to the bottom terminal of the NC contact points on the reverse run contactor. Connect the upper terminal of it to the A1 of the forward run contactor. Now take another line between the start and stop push-button switches and connect it to the A1 through the NO points of the forward run contactor. This additional line, also called the latching circuit, will ensure that the contactor will remain in its on position, even after the start push button is released. Now connect the neutral line to the A2 end of the contactor operating coil. For reverse contactor wiring, take the connection from the output terminal of the stop push button to the reverse start push button. Take the other end of it through the normally closed contact points on the forward run contactor and connect to the A1 end of the reverse run contactor. Connect the latching circuit through the NO points to the terminal A1. Complete the reverse contactor wiring by connecting neutral wire to the terminal A2. Star-delta contactors will receive control power only through the timer. In addition, the timer will receive control power through the NO auxiliary contact points of the forward and reverse run contactors. Therefore, join the lower terminals of the NO contact points of the forward contactor, although I have shown that the line is branched from the middle. Next, connect the upper terminal of the unused contact points set to A1 end of the timer. Likewise, connect the latching circuit line of reverse contactor 2 to the A1 end of the timer. Connect the neutral line to the A2 end. Now connect the control line from A1 to terminal 25. Terminals 15 and 25 are the control power input to the timing units. To select the output to the star or delta terminals as appropriate. 18 and 28 are the output terminals of the timer to the star and delta contactors respectively. So connect the terminal 28 to the A1 coil end of the delta contactor. For interlocking purposes, this line is taken through the NC contact points of the star contactor. Connect the neutral line to the A2 end. Next, connect terminal 15 also with control power, and the output terminal 18 is connected to the A1 coil end of the star contactor. Control wiring is completed after connecting the neutral line to the A2. Let's see how the system works now, and first we'll consider forward operation. When the switch is turned on, power is available at both push-button start switches. When the button is pressed, the forward contactor is energized and the two normally open contact points are now closed. Before the start push button is released, A1 obtains an alternate power path through the latch circuit. So releasing the push button will only remove power from the right-hand side to A1, but the latching circuit continues to hold the contactor in its energized position. At the same time, the timer gets power through the other set of NO contacts, which are closed now. First thing the timer will do is release power to the terminal 18 and energize the star contactor. Now the motor starts running in the forward direction, the motor requires running on a star connection until it reaches around 80% of its full speed only. Then after about 3 to 4 seconds, the timer stops power to its terminal 18, thereby the star contactor is deactivated. These times can be adjusted on the timer, according to the requirements of the motor. Now both contactors are at off position, and this very small delay period of around 50 milliseconds is there to stop any short circuit between star and delta contactors during changeover. After this pause time, the timer releases power to its terminal 28, thus energizing the delta contactor. So the motor operates with delta connection until you stop it. When you press the stop push button, control power is terminated from there, and the forward run contactor, timer, and delta contactor are turned off, and the motor stops. When the stop push button is released, 2 start push buttons receives control power. Also the bottom terminals of NO contact points on the forward and reverse contactors receives power. Let's check the reverse running of the motor now. When the reverse push button is pressed, A1 receives control power. Therefore the reverse contactor is now energized. Latching circuit 2 is on now. So releasing of start push button will do no harm. Also, the timer gets power now, and the star contactor is energized. Motor runs on the reverse direction now. After the pause time set in the timer, the delta contactor energizes. The motor is now running on delta connection, and will continue to run on delta connection until you stop it. I hope you have a good idea now about the control circuit wiring for a star delta starter with motor reversing option. If this video is useful, please subscribe to the channel. Thank you.